Last little bit talking about the memory of the humoral immunity. So again, it's going to be B cells that make clones of themselves. So they make the clone of themselves. Then they differentiate into plasma cells. And most become plasma cells, but you're going to have memory cells. So we talk about primary and secondary immune response. So what happens is when the primary immune response, it's the first time you've been exposed to it. So it's first time that the B cell has ever met its match and its soulmate. So cell proliferation and differentiation. So again, same thing, B cells cloning themselves, which is proliferation, and changing into plasma cells and memory cells can take a little bit of time. So the B cell activated, meets its match, and then does multiple kind of clones, and then they become plasma cells, and then they produce antibodies. So it can take a little bit of time. Antibodies. So you have what we call a lag period of 3 to 6 days while this is occurring. So it takes time for this to occur, division to happen, differentiation to occur. So you actually take time before you're able to properly fight off the infection by producing antibodies. So 3 to 6 days of differentiation and proliferation to get to plasma cells that are starting to produce antibodies. So if it takes 6 days, then they're pumping out as many antibodies as they can, all the plasma cells, but that takes time as well. They have to produce those proteins. So peak or highest level of plasma antibody levels, again, plasma is going to be where it circulates in the blood, is going to be after 10 days after exposure. Afterwards, if we've taken care of the antigen and we're not being exposed to it anymore, so you don't see any more activation of B cells, the antibodies, then all of a sudden peak. And then once they're done, they decrease because they're not exposed to the antigen. So they decline. So it kind of is that mountain. So we're looking at two different classes of antibodies. Remember, IgM is the largest, that pentamer, and that's the first one to be produced. And this is time on the x-axis in weeks, not days. So 10 days is between 1 and 2 weeks. So about 10 days, we have our peak IgM levels, which are the first one produced. And then they quickly decline after that. IgG is the second one being produced, but it kind of has a peak around 2 weeks and then decreases after that as well. So it just depends on what the plasma cells, which class of antibodies those plasma cells are producing. In the secondary immune response, this is the second time you've been exposed to the same antigen. So the B cells are ready for you. So this B memory cell is going to react faster. So it's going to be ready to divide faster and make more clones and then plasma cells and antibodies. So it's a faster reaction and it lasts longer. So you're not going to see this kind of quick increase and then decrease. So you're going to be ready for it and you're going to be kind of prepared a lot longer. And it's a larger response. So instead of having this kind of slow mountain, we're going to have a really fast increase and it's going to stay up like that. We'll see in a graph next. So instead of having that 3 to 6 day lag before you're even ready to kind of increase your antibody production, it can be hours. That's a lot faster, 3 to 6 days versus a couple hours. And your peak becomes 2 to 3 days instead of 10 days. And again, it's at higher levels. So not only do you reach your peak of your mountain a lot faster, you actually are a lot higher and there's more antibodies produced. We also say that antibodies bind with greater affinity, meaning they really stick to whatever antigen they find, or what antigen they're supposed to fight against. So they will come along and attach to the antigen that they find, and they're really not going to be torn apart from the antigen at all. And then again, prolonged, it can stay antibody level high for weeks to months. So even if the disease or the pathogen is around for longer, then you can have antibodies that stick around a lot longer in circulation. So if there's another exposure, you don't even need the B cells to start changing and do all of that. You already got the antibodies around. So having the antibodies in circulation makes it even faster. So again, this is looking at it. IgM is kind of the similar, so it is more kind of the first response, but look at IgG. That's our major secondary response. So IgM does similar both ways. So it's going to come up, peak, and come down. But IgG, look at it goes a lot faster to get to even where peak would be for IgM, and then it keeps going and it stays a lot longer. So again, looking at the difference, the secondary response, there's a lot higher. And even the IgM, even though it's kind of similar peak looking, look where it does. So look where it is here versus where it is here. It's shifted. 1 week here, it's already becoming peak a lot faster in a couple of days versus past the 1 week mark over here. And look significantly the IgG, you have a huge response and a lot longer. And we use this to our advantage. Again, if you get the flu and the first time you get really, really sick because it takes longer for your immune system to actually fight it off. If you were to get that same flu strain a little later, well, you're going to have a lot faster reaction and you may just kind of feel a little blah one day, but not down and out, not being able to go to work or school or anything like that, and really, really sick laying on the couch. So we use this to our advantage. That's why we have vaccines. So the first vaccine is going to be where you kind of prime or primary response, where you'll have some antibodies. And then if you have another booster, the more boosters that happen, then you're going to have this response if you're exposed to it, even if you only have one dose of the vaccine. So you have this. And then you're exposed. So you say again, measles. So you have the measles vaccine. This starts, but then you have memory cells. So if you were exposed to the measles later in life after you've been vaccinated, say a year later, you're actually exposed to someone that has the measles that could give it to you, well, you're going to have this response. I'd much rather have this response in fighting off the measles than this response. So that's where we come into play with vaccines, are taking advantage of the memory and remembering what the antigens are and being a lot faster in response.